Um, are we on? Uh, okay, I think we're good. I'm just going to say from the back, I have a delivery waiting, which is bad timing. So if I need to go in between just to deal with that, then I do apologise for like a 5-10 minute gap. But I'm going to try and just make this as smooth as possible. Anyway, so with that all said, this is a revision stream again for paper 2. The idea of this is obviously it's the night before. Well, I guess becoming towards the night, like 6 o'clock in the afternoon. Um, but obviously, the idea with this is to not do a full past paper, not to do like loads and loads and loads of topics. I have collected 58 marks worth of questions. And these questions, as in the title, these are going to be very, very, I think, important questions. That because they're not come up in paper 1, and I've seen them, they come up every single year. You're gonna, it's going to be extremely important that you do know these to pick up the marks. Okay. So I picked up 58, so hopefully it's not going to be as long as I usually do to give people a break, and also for me because I'm doing A level revision after this as well. Because the A level exam and the GCSE math exam is both on tomorrow. So I'm going to do 2 streams, but this is the GCSE one. But you don't have to worry about that. But I'm just saying, for this, it's 58 marks. Hopefully, when I picked the questions, I didn't think they were going to be too bad, but then I tried them. And there are some good ones there. Let me just say that. So this would be, I think this would be good for all types of people, really. And so because it's higher, the first few questions would be for foundation as well, but it is going to be aimed at higher, really. So bear that in mind. Okay, I need to get the chat on as well. Um, let me check the chat. Uh, oh yeah, you okay? Anyway, so I guess we should get started. So, question 1. Um, so this is an index law question. They love to ask these. I'm surprised it didn't come in paper 1, but it will most likely come up in paper 2 or 3. But you need to know this sort of thing. Anyway, so index laws, question 1. Um, so first of all, have to simplify m to m cubed times m to the 4. So these are just power laws, right? So you need to know that a to the m times a to the n. So if you're times in the base with the same power, you add them, right? So in this case, m to the 3 add m to the times m to the 4. You're going to add the powers, right? So it's going to be m3 add 4, which is going to be m to the 7. Cool. So that's just one mark. Cool. So in part B, we have this here. 5np cubed all cubed. So, with this, you need to recognize this power law here. A to the m, all raised to a power of n, means you need to times the indices. And basically, every single part in the bracket gets raised to the power of 3. So, what this means here is first of all, we have a 5, so it's going to be 5 cubed. And then we have an n. So n, obviously that has a power of 1, because remember anything that's on its own really has a power of 1. So that means n to the 1. Then using this law, 1 times 3 is going to be 3, right? So it's going to be n cubed. And here we have p to the 3, and we're going to times by the 3, right? So that's going to be 3 times 3, which is 9. Okay. Cool. But we need to do something else. I think we can do something with this 5 cubed, right? Because it's an actual number. Don't start. So 5 cubed. Well, what's 5 cubed? Well, it's 5 times 5 times 5. You can put that into the calculator if you're unsure, but that would be 125, right? And then we can just put n cubed p to the 9, and that will be your answer. Okay, the most common thing to pay attention with this here is you need to raise everything in the bracket by the power of 3. Okay, don't just like say p to the 3 times 3 is 9 and then leave out 5 and n. Every single bit has to be raised to the power of 3. Okay, cool. So part C, now we have 32 q to the 9 r to the 4 over 4q cubed r. Okay. So again, this you're going to need this power law. You should remember a to the m divided by a to the n. This is a division, obviously. And then you subtract the powers, right? M minus n. So that's what we're going to do here. And again, like with this bracket, we do each bit separately. So again, let's deal with the number, right? 32 over 4. Well, that's just a division, right? 32 divided by 4 is going to be 8, right? And then we have this q. So we have q to the 9 over q cubed. Using that power law, we're going to subtract the powers, right? So it's going to be q to the 6. And then we deal with the r bit. So then r to the 4 over r. Again, that has a power of 1, really. So it's 4 minus the power subtract. So 4 minus 1 will get you r cubed. So then if we bring it all together, we're going to have 8 q to the 6 r cubed. And that should be your answer. Okay. Yeah, so it's fairly common you get a question like that. Like just making sure you know your index laws. Okay, I'm going to move on. Okay, now we have a density question. Again, they love asking this sort. It's either to do density or speed. But here it's density. Okay, so let's read. Liquid A has a density of 1.2 grams per centimeters cubed. 150 centimeters cubed of liquid A is mixed with some of liquid B to make liquid C. So essentially, liquid A and liquid B makes liquid C. So we need to remember that. Liquid C has a mass of 210 and a density of 1.12. Find the density of liquid B. So with this sort of question with density and you have 3 different stuff, it's best to do it all separately. So liquid A, what do we know? And also we're going to need this triangle here. So you should remember we have M, D and V, so mass, density and volume, which will help out here. So what do we know about liquid A? Well, we actually know the density is 1.2. What about the mass? We don't know anything about the mass. So then what about the volume? We know it's 150. So it's probably a good idea then to work out the mass. But how do we work out the mass then? So we use the triangle here. So if we cover up the mass, we're just left with D times V. So the density times the volume. So that means your mass will be 1.2 times 150. I'm going to add that back. And then you put that into the calculator. That will become 180, I believe. And that being grams, but we don't worry about the units just yet. So that's liquid A. Let's have a look at liquid B then. What do we know? Again, the density. Well, we don't know the density, and that's what we want to work out. What about the mass? We don't know anything about the mass either. What about the volume? Oh, we don't know anything about the volume either. So we have to leave all that there. So let's consider liquid C. So again, the density. Well, we're given the density of 1.12. We're given the mass of 210 actually, and the volume we don't know, but we can work out the volume. So again, if we cover the volume here, then it's just m over d, so the mass divided by the volume. Okay, so that'd be 210 over 1.12. Put that into the calculator. You're gonna get 187.5. Okay, now we need to work out this bit for liquid B. So we need the density, so we're going to need the mass and the volume. But actually, you should know with these sort of questions that if we're combining stuff together, we can add the mass and the volume. So that means the volume. So first of all, the mass of liquid B. So what's happening is liquid A add liquid B. Remember, is making liquid C. So actually, if we add the mass of A and B together, we get the mass of C. But we know the mass of C and A. So therefore, the mass of B is going to be the mass of C, which is the total, minus the mass of A, which we found out to be 180. So that would be 30. Okay. Likewise, with the volume, we can add the volume together as well, because if two things come together, they will occupy the same. The volumes will add together. They'll occupy the space. So we can add them together. So the volume, again, we add the volumes of A and B to get C. Well, we know the volume A is 150, and the volume of the total of C is 187.5. So therefore, the volume of B has to be the difference, right? And that's going to be 187.5 minus 150. So then if you take that away, you get the volume of B to be 37.5. So now we know the mass and the volume, right? We can fill this in. 37.5. That's a V, not an L. There we go. So now we know the density. Again, we can use this triangle. The density, according to the triangle, will be mass divided by the volume. So therefore, the density of B is going to be the mass, which was 30 over 37.5. And then if you work that out, you get 0.8. And I guess the units, although I didn't ask for units, but it would be grams per centimeters cubed, right? Okay, and that's it. So that's sort of the strategy with these sort of questions. When you got loads of stuff together like this, you just do it one by one, and then you can work out the missing information using this formula here, and recognize that the mass and the volume will just add together, but the density does not. This is why we have to split this up, because the density does not add like this. Okay, let's have a look at question 3. Whilst okay, so we have a ratio question. So we are told last year a family recycled 800 kilograms of waste. 57% of the waste is paper and glass. So I think straight away finding 57% of this will be very helpful. But let's have a look. Then we're told the weight of paper recycled to the glass recycled is 12 to 7. So we know a further split between paper and glass. Work out the weight of the glass. Okay, well, first of all, we're going to need to find the weight of the paper and the glass. Well, that's given by this percentage here, isn't it? So glass and paper, that's going to be 57% of 800, right? But you should know we can convert this into a multiplier, which obviously divide by 100, which should be 0.57 times 800. And that will get you 456. Okay. So that's, and that being kilograms, and that's how much glass and paper we have. Then we're told about this split, so how the glass and paper split. So the weight of paper to glass recycled is 12 to 7. Um, well, actually, I guess if you think about it, you can add up these parts together to get 19 parts in total. So in total, 19 is paper and glass. But we know in total it's 456. So you could say 456 divided by 19 is worth what? 24. But then that's worth one part, right? So one part would be 24, but we want 7 parts for the glass. So we could times that by 7 to get the actual value, and that would be 168. Alternatively, I guess, well, it's the same logic, but you could say, well, perhaps again, there's 19 in total, so the glass is going to be 7 out of the 19, right? 7/19 of the paper and the glass. So you could just times 456 by 7 over 9 over 19, and that would get you straight to the answer. There's many ways of looking at this, though. But yeah, expect a ratio question like that. You know, there will be. They love asking ratios on every paper, so just something to be aware of. Okay, hopefully that made sense. Okay, question 4. So again, error. So this is an error interval question. Again, it's like a 2-1 marker, 1 marker, 2 marker, but they ask it every year. So it's just something you need to again just be able to do. So error intervals then. So we're given a number d, which is rounded to 1 decimal place, and the result is 12.7. So it said find the error interval, and they're kindly giving us the interval already. We just got to put the numbers in the right place. Okay, so what is it saying? So it's basically bounds. It's asking for the bounds of D. So the lower bound, the lowest number D could be on the highest. And it's due to the fact it's rounded. So when we round the number, we introduce a bound. So let's explore this. So the way I like to go about this, I think the best way maybe, is well, 12.7, it's rounded to 1 decimal place. So what would be the next number to the next decimal place? It would be 12.8, right? Because we're going up by 1 decimal place. And likewise, if we go backwards, we would have 12.6, okay? So we're going backwards and forwards with 1 decimal place. So this is helpful then. Again, I guess if you visualize it on the number line, 12.7 would be in the middle, then the next number would be 12.8, and then the last number would be 12.6. We essentially need to find the lower bound, so the lowest number that will round up to 12.7. That's going to be in the middle, right? Because it's going to be 12.65, and the 5 will make sure that the 6 will round up to the 7. So that will be your lower bound. And again, the same argument, the upper bound will be in the middle between 7 and 8, so it's going to be 12.75. Okay, so that'll be your upper. And something you need to know, it's a strict inequality. It cannot be 12.75 because obviously the 5 will round that 7 up to an 8, not down to a 7. But then if you imagine the number before it, 12.74999, so on, that will all it's infinite, right? We cannot actually write this number down, but we know it would round down to 12.7, which is what we want because of the 4 here. So any number before it, before 12.75 will round down, but not that number. So we have to be strictly less than. Okay. Okay. Alternatively, as well, if you be a bit quicker, it's going to be if we again list the numbers, the next decimal point forward and the decimal point before it, it'll just be in the middle. Okay, so it'll be 12.75 and 12.65, and that's your bounds. Okay, it depends how you want to see it, but that's essentially what the error interval does. It gives us the bounds. Okay, question 5. And this is Venn diagrams. Again, so this comes with every year as well. So it's really good to know it, right, to pick up some marks. Okay, so we have uh, this weird Z calligraphy thing here. That essentially means every possible number we consider, right? Every possible outcome. So here it's telling us we have to consider every odd number less than 30. So that's going to be at 1, 3, 5, 9, and so on, all the way up to 29, which is the last odd number before 30. So that's telling us that this list of numbers is what we need to consider and put down in the box. Okay. Then we have A, B, and C. So these represent the circles. So again, these are just a list of numbers. And it told us A is 1, 5, 7, 23, 29. B is that, and C is that. Okay. So we need to fill in the Venn diagram. So the best way of doing this essentially is to work out when they all overlap and then work your way out. So work with when they all intersect, which is here. Then when they intersect only between two of them, and then when they just are on their own, right? A and B and only A, B, and C, and then outside the box. Why is that helpful? Because it's a lot easier to work out what's in the box, and then you can cross the numbers out, and then you can work your way out. It's a bit trickier when you start like in when the box when you're in the circle on their own, and then you work your way back in, and the numbers are a bit more tricky that way. But anyway, let's just get on with it. So, what's in the middle? So that's going to be when a number from this list is going to be in all three of these, A, B, and C. So the best way to do that is to let's have a look what number is in all three of them. So what about A? What about one? One is only in A. What about five? Five's only in A. What about seven? Well, seven's in A. It's in B and it's in C. So actually, that 7 is now in the middle because it's in all three of the lists. So it'd be in all three of the circles. And if you want to, you can cross that off because we're done with that. Then what about 23? No, 23 is only in A. And then what about 29? Well, 29 is also in B, but not in C. So we leave that. So we filled in when they all cross over, that all overlap. Now let's do when only two of them overlap. Um, so again, let's start with A. So one, again, one's only in A, just leave that there. What about five? Five's only in A. What about 23? Well, 23 is also only in A. And then 29. Well, 29's in B as well. So that'd be in A and B. So that'd be 29 there. And we can cross that off. Okay, so we dealt with A. Then what about B and C? So 11 is only in B, 15 is in B and C, so we can put a 15 here, which is where B and C overlap, which is there, and then that's it. And then the remaining numbers we just have to put in the circles on their own. So A would be 1 and then 5, and then B would be 11, and then C would be 17, 19, 25, 27. Okay, hopefully that made sense so far. Um, So, and that's what, that's a good thing. So that's why I said earlier to consider the overlap first and then work your way out, because you can cross out the numbers and then you can just simply add the remaining numbers in. It's a lot trickier the other way around. But yeah, that should be the numbers we've got. However, that's not every number because remember, this original list here is all the numbers we have to add. We have to add every number in this list in the box. So if it doesn't belong in either of these three lists, it has to be in its outside space here. So that means if we don't pick a number from A, B, and C, it's everything else. Okay. So what numbers are remaining? Well, one, you can write them all out if you want to, but um, I think we might be able to manage without doing that. But what about one, first of all? Well, one is an A, so no. What about three? Three is in neither circle, so we can write that outside. So we could say perhaps three here. What about five? Well, five's in A, so no. Seven's in the middle, so no. What about nine? Nine's in neither, so we can write nine. What about 11? Then 11's nope. Then 13. Well, 13's in neither, in neither circle, so we can write 13 out here. 15. 15's over here, so no. 17, again, no, it's over there. 19, again, that's in C. Oh, then 21. Well, I don't see a 21, so that would be outside. Then 23, I don't see a 23 either. and then a 25 is there, and then a 27 is there, and a 29 is there, and that's all the odd numbers between 1 and 30. So we have completely filled the Venn diagram. Okay. And the thing to note is that every number can only be in the box once. So like that's what I did here. So I noticed there's a 5 in the A, so I don't write another 5 again. So that I can rule that out. And that's why I crossed the numbers out as well. That's the main bit. But hopefully that made sense. Um, okay. Now we are given a number that's chosen at random from the box here with this weird sign. So the box, that sign just means it has to be in the box, right? Essentially. Don't worry too much about that sign. So we chosen a random from the box, from the probability that the number is a member of A and B. So the number that is in this sort of category here. Well, you need to recognise that this sign means the intersection formally, but that means and really. And the way I like to remember it is and has a lot distinctive N sound, like and and it has, and this was like an N as well. So that's how I remember it. In the same way, you might see this symbol, which means the or union, depending, and that and or has like a U, almost like a U sound, like like U. I don't know. So that helps remember or the U shape as well. But in this case, we have the N, so so it's the and, right? So that means it's A and B. So any number that's in both A and in the circle A and the circle B. Okay. So what numbers are in A and B? It's going to be this number here, this number here, and that's really it, isn't it? When the two circles A and B cross over, these are the only two numbers we get, right? So it's going to be 2 because that's how many numbers there are. And the total, again, we're choosing from the box. So how many numbers are in the box in total? So it's going to be 1, 2, 3, 4, 5. And then inside the circle, you're going to have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the total will be out of 15. So the amount of numbers in this, the probability of choosing in A or and B will be 2 over 15. Okay. Cool. So that's a very again. All of these are kind of standard exam questions as well. At least on the higher papers. So that's how you. I would expect a question to look like this. Maybe on paper 2, but if not paper 3. But it's very good practice, right? Okay. Let's move on to question 6. And I'll just at this point, this is where it's higher only. Okay. Because box plots is grade 6, and that foundation only goes to grade 5. So at this point, it's higher only. But yeah, there's the question there. So let's have a look at it. So we are given box plots. So again, box plot comes up every year from what I've seen. Um, and it follows the same structure of question every single time. So they ask you to sum it, then they ask you to draw a box plot, and then they ask you to comment on it. And we'll see that in a minute. So we're given the box plot about sales in an online store. Andrew says 3/4, I'm going to say 3 over 4 here, of the given data lies between 160,000 and 350,000 because these values are the lower quartile and the upper quartile. Why is he wrong? I'm going to say off the bat. So when they ask you something about, oh, is this person wrong? 90% of the time they are. That's because that shows you being critical, and that's what the examiners like examining as well. But anyway, he's wrong in this case. But why? So the we need to think about the lower quartile and upper quartile. So the lower quartile is going to be here. This little I can draw a line there, and the upper quartile is going to be there, right? Now, what percentage is in between? Well, we know that the lower quartile is 25% from the minimum, and the upper quartile is 75% of the data or 25% from the maximum. Okay, that's how we design it. So therefore, what's in between? It's going to be 50, right? But 50 is not 3/4. So he's wrong. So he's wrong because uh, a half of the data lies between the lower quartile, I'm going to call it LQ, and upper quartile UQ. I think this should be fine with this abbreviation because it's very common with box plots. So I know what you mean. So it's a half and not a 3/4, right? So that therefore is wrong, and hopefully you can see that, right? Okay. Then we are told a table shows information about the sales of a shop. Okay. So remember the last one was about online. Now this is about in the shop. So we need to draw a box plot, and again, this is fairly common. They give us the data, and we need to plot the information. So the biggest difficulty with box plots is actually, I'm going to actually zoom in here because it's a bit tiny when drawing. There we are. The biggest problem with box plots is actually you need to work out the scale, but that's not too difficult, hopefully. So what do I mean by that? Well, I need to see what each of these small boxes here, what does each small box represent? So one small box. Well, I know there's a 10 of these boxes is 100. So that means one box is going to be 10. Okay. And that's our scale. Okay. Now, with that in mind, we can plot the information. So, first of all, let's start with the least. So that's 30. So 30 is going to be, hopefully you can see it here. Right. So that's going to be like there. Then the lower quartile, the next bit's going to be 80. So where's 80 going to be? It's going to be there, right? So it's going to look there, roughly. Then we connect them with a line. Then we need to deal with the median, which is 170. So that's 150. So then 170 is going to be there, right? So then we draw a line on the median, which is there, preferably with a ruler, but I don't have one. So I have to freestyle it. Hang on, I want to make that a bit more clear, actually. A bit straighter. There we are, 170. And then what I'm going to do is, obviously, between we have to then draw a box, so then I have to draw a line on the up, connecting it on the top and the bottom. Then we need the upper quartile, which would be 260. So again, that's going to be here, right? Because here is 260. Because if that's 250, the big line, then the next one's 260. Okay. And again, I'll continue the box here. And then we draw the maximum, which is 350. And that's obviously going to be this line here. And then likewise, then we draw a line in the middle to reach out to it. And that's how you plot it, right? And and in this question in particular, they're quite nice because if you ever forgot how you structure the box plot, they give you another example here. So if you forgot to draw a line in the middle and draw a box, there's another example to help you out there if you forgot by any chance. Okay, cool. Okay, and the part C is now asking to compare the distribution. So that's the key command here between the online store and the sales in the shop. So remember, I talked about the first one was online, and this box plot we draw was in the shop. So we need to compare the two box plots, right? Which is again very common. And with this, you need to compare two things, right? First of all, you need to talk about the average. and this is the median. Okay, so let's have a look at the median of the two datas. So the median here, and remember this is for the online store, the median is going to be 200, right? So then what about here? What's the median here? Well, the median is 170. So actually the median in the online store, which is 200, is higher than in the shop. Obviously, as 200 is greater than 170, which means that therefore the sales in the sales online are higher than on average, because this is an average, but on average you can say the sales online are higher than in the shop. Okay, and that's your first point. And then the second bit you always compare for 2 marks, for two things you need to point out, is the spread of the data. So that is talking about the IQR, so the interquartile range. So how do you work out the interquartile range? Well, it kind of hinted about it in part A. That is the upper quartile minus the lower quartile. So the range is essentially, again, this 50 here, this 50%, this range here, between the lower and the upper quartile, this little length from the top. So if this, well, here the lower quartile is, if we read off the graph, 160, and the upper quartile was 350, right? So therefore the interquartile range will be 350 minus 160, and that's going to be 190, right? Now, what about the interquartile range in the store? So again, we've actually given the data here, so we can say the interquartile range is the upper of 260 minus 80, and that's going to be 180. So let's have a look. So the interquartile range of the online is 190, but the interquartile range in the shop is 180. So actually, again, 190 is bigger. So the interquartile range in the online is going to be bigger. So the IQR of the online the online store is bigger or greater than the IQR of the shop. And again, that's because 190, which is the IQR of the online store, is bigger than 180, which is the interquartile range of the shop. Therefore, the spread of the sales online is greater than in the shop. Okay, and what that means is essentially if the data's like this, then it's more spread out. But here, if they're more tightly packed together, they're less spread out. So they're more closer to the mean, to the median, right, to the average. But there's more spread, so there's more variance or whatever. But those are the two things you must remember. Always with this box plot, when you compare stuff, you talk about the average and you talk about the spread, which is the median and the interquartile range. Okay, I'm going to zoom out now a little bit. So question 7. Um, so we are told Aaliyah bought a car. In the first year she bought the car, its value depreciated at a rate of 23% per annum. Annum, it just means per year. Right? In the second year after she bought the car, its value depreciated at a rate of 19% per annum. Okay. At the end of the second year, the car was worth that amount, What was the value when she bought it? So this is a reverse percentage question, which again is very common. They ask it every year. So you're given some percentages, and then you get the end amount. You need to find the start amount. So the best way again, it's just a bit of algebra, really. I think that's the most clearest way, rather than trying to do it backwards. How do I reverse this? How do I reverse this step? How do I reverse that? And then a bit like, what do I do? So I think just go through the normal way. Um, and to do that, I'd say well, obviously x again is going to be what we want. So that's the value at the start. Then it's told in the first year this value x is depreciated, which means goes down or decreases by 23%. So if it's going down, if it's decreasing by 23%, that means the amount that's left is going to be 100 minus that, which is going to be 77%, right? So that's your multiplier. So 70%, 77% of x is what's left, and that's the end of first year. Now, after that year, the second year, it goes down again by 19%. So all of this, again, x times 0.77, 19% of this goes away. So that means you're left with, again, 81% after. So that is your multiplier in the second year. So we can times all of this by 0.81, because remember, divide it by 100, you get 0.81, which is what your multiplier, right? So that's what you're timesing by to get 81% of the amount. And that's the second year, but we're told at the end of second year it's worth this. So this amount here has to be 10,914.75. So actually then we just solve this for x, right? So first of all, let's simplify this. X times 0.77 times 0.81. Let's do 0.77 times 0.81 in the calculator. And you get this number here. X times 0.6237 is this number here, 10,914.75. Oh, hang on a second. Okay, apologies. So yeah, so to then solve for x, well, if we times it by 0.625 here, 6237, sorry, I don't know what numbers I'm saying. You're going to divide, right, to get rid of it, to undo it. So if you divide both sides by 0.6237, we're going to get that x is 10,914.75 divided by 0.6237. And if you go down, oh, that will get you, if you put that into the calculator, you get this number here, 17,500. And that's the value when she bought it in pounds, right? And yeah, that's how you approach that. So reverse percentages, again, the strategy really just let the original value be X or anything. Then you just go from there. So normally you type on 77%, and then 81%. And then that's your value, then just solve for X. But yeah, that's really that. Okay, moving on swiftly. Question 8. Jeff is choosing a shrub and a rose tree for his garden. At the garden centre, there are 17 different types of shrubs and some rose trees. Jeff says there are 215 different ways of choosing one shrub and one rose tree. Could Jeff be correct? So this is a combination question because it's asking about different ways of choosing stuff, right? So this is the combinations or the product rule counting, and you'll see why it's called that. if you haven't done it already. Well, what this means is when you're picking a thing from two different lists. So here we have a shrub and we have a rose tree. If we are picking one shrub from the amount there are, so again the total is 17 types of shrubs, and there are some amounts of rose trees, so that's going to be X number of types of rose tree. If we're picking one from each category, the total combination of picking all of these is going to be the times in the amount together. So it's going to be 17 times X. Okay. And and they're told that the total amount of choices is 215. Okay. And to reiterate, that's because we're choosing one shrub and one rose tree. So pick one from each. So that means you time them together to get the total amount of options. Well, we're just left with the equation 17x is 215. So again, we solve it. Divide both sides by 17. We're going to get x is 215 over 17. What does that get us? Well, actually, you get this decimal number here, 12.647. Now, actually, what is this saying? So it's asking, could he be correct here? Well, again, like I said earlier, 90% of the time they're going to be wrong. And here, you can kind of say they are. Because x represents how many rose tree types there are. You can't have a decimal amount of that. You can only have a whole number. So as x is decimal, x is not a whole number. That means that there cannot be 215 different ways, which means Jeff is wrong. So as x not a whole number, Jeff is wrong. Okay, because that doesn't give us a whole amount, a sensible amount of rose trees, right? You can't have a decimal amount. So therefore, he must be wrong. Okay, so again, expect that for 2 marks. If you are confused by it, the safety thing is just times them together, right? 17 times how many you get is 215, and then just go from there. Just times them together if you're a bit confused by that. But that's how these counting questions go, about 90% of the time. Okay, and again, that's only 2 marks, but every mark helps. Okay, question 9. This is where it's going to start ramping up now. They've got the grade 7 stuff now, the A star. So question 9. So we're given ABC as a triangle. So calculate the side of angle BAC. So the first step really, again, is to work for the unknown value x, or identify what the unknown is or where it is. So it's this angle here, BAC. So the letter in the middle, remember, is where the angle is at. So if it's at A, then it's at the angle at A. Okay. So the other thing to note is it's just a triangle. There's no right angles, which means you cannot use SOHCAHTOA or Pythagoras because they only apply to right angle triangles because of the fact there's a hypotenuse, right? Which comes from the fact there's a right angle. When there's not a right angle, there's only two things you can really do: the cosine rule or the sine rule. And that the cosine rule is a squared is b squared plus c squared minus 2b c cos a, and the sine rule is what's it? Sine a over a equals sine b over b. Okay, so the strategy of this really, the cosine rule and sine rule. Cosine rule deals with three lengths, right? All three of the sides, because it has A, B, and C. Sine rule deals with two angles because there's two angles involved. That's not happening in the cosine rule. So if we know if we're dealing with two angles, that's the sine rule. If we're dealing with three lengths, it's the cosine rule. But let's have a look what's going on in this question where we have one angle and we want to find another. So there's two angles involved. That means we're probably going to want to use the sine rule. So let's consider that then. So what well, okay, the sine rule. Um, well, with this angle here, A will be whatever. It works with the only with the opposite side. So here, the opposite of the angle X is this side here because it's facing this side here. But we don't know that side. But we know that this angle's opposite to here, which we know, 18. Um, but then what about the other angle here? Well, we can work out this angle, can't we? I think we call that Y. I think we can work out Y, and then we know all three angles. And then I think that 180 is the sum of them. Yes? So I think working out Y is a good first step. So let's apply the sine rule. So it's going to be sine of Y over the side that's facing it, which is going to be 15. So that's going to be sine of the other angle, which is 70. And then the length facing it is going to be 18. And that's the sine rule. So now we just need to solve for Y. Well, you can cross multiply if you want to. So you could say that 18 sine Y is 15 sine 70. Therefore, hang on a second. I don't know what's going on the door today. Anyway, so we got to that point. So now we want to sine Y on its own. Well, if we feel comfortable, if you don't feel comfortable, sorry, 18 sine Y, let's just evaluate this first. So let's do 15 sine of 70. That's going to give you this result here, 14.095. And then you type, and then how are we going to get rid of this 18? Well, we times in 18 here, we're going to have to divide by 18 to get sine Y on its own. So sine Y is this result divided by 18. Hopefully you can see that. And therefore you get this number here, 0.783077 and so on. So then how are we going to get Y? Well, we're going to arc sine it. We're going to do the inverse sine, aren't we? So inverse sine of that is going to get us this angle here of 51.543 and so on degrees. Okay, so that's Y. But now now we know two angles here. We know Y and which is 51 point something. And we know this is 70. Now we know the other angle X, because all the angles in a triangle have to add up to 180. So therefore, we know that XZ is going to be 180. The total take away 70, take away the other angle Y, which is 51.543, which gets us this number here, 58. So that will be 58.4568 degrees. What does it say to leave it in? To one decimal place. So to one decimal place, that would be 58.5 to 1 dp. Cool. So yeah, the general strategy again with non-right angle triangles with cosine and sine if you're dealing with two angles, you're going to want the sine rule, likely. If you're dealing with all three of the length, it's going to be cosine. Okay. But here we have two angles to work with, so we had to use the sine rule. Okay. Okay. So question 10 is quadratic sequences. Again, that comes up every year. So what is the strategy? Quadratic sequences. Again, if you have your own method, obviously stick with that. That's fine. But I'll give a different way of doing it if you haven't done this way anyway. So let's start with just writing out the sequence again. The 1727. What we do here to find the nth. So remember, if it's a quadratic, the nth term is going to look like a quadratic. It's going to look like an squared with bn plus c. Okay. So we need to find a, b, and c essentially to find all the missing values. Okay. So what we're going to do? So we have this sequence here. What we're going to then do is work out. Well, how would you deal with a linear sequence? So say if you had 7, 12, 17, and so on, you'd find the difference, right? Which would be 5 and 5. That's kind of what we're going to do here as well. So we're going to consider the difference. So here, the difference here is going to be 6. The difference here is going to be 8. 17 minus 9 is 8. Then the difference here is 10. Okay, so it's not exactly the same amount, but then what about the next difference? That's 2 and that's 2. This is the same. So if this is the first difference, the second difference, and what will always happen with quadratic sequences, this will always work the same way. You will always get the same number in the second difference. Always, always, always. So what that means is actually, I'm not going to go too much into this, but that means 2a is 2. This number here is 2. The way you can think of this, I guess, without going into the technicalities, it's the second difference. There can be two lots of a. Okay. Um, so 2a, because the second difference is equal to 2, which is this number here. If this was 3, for example, then 2a would be 3. Okay. But here, obviously, the difference is 2. So 2a is 2. Then that means a is going to be 2 divided by 2, which is 1. So now we can start to do more with this, right? We can say it's n squared, 1n squared. So it's just n squared and bn plus c. So how are we going to find bn plus c? Well, again, we're going to write the sequence out, 3, 9, 17, 27. Now what I'm going to do is consider the term n squared, right? So an squared, here it's 1n squared, which is obviously 1, so just n squared. And then I'm going to plug in values for n. So when n is 1, you're going to get 1 squared, which is 1. When n is 2, you're going to get 2 squared, which is 4. When n is 3, you get 3 squared, which is 9. And then when n is 4, you're going to get 4 squared, which is 16. Why? Because that's the first term, the second term, the third term, and the fourth term. So that's when n is 1, 2, 3, 4. So that's why we plug the n in those sort of values, right? Because bear in mind the totals, it's the first 4 terms of the sequence. So that's when n is 1, n is 2, n is 3, n is 4. Hopefully you can see that, right? And it will always be like that. It will always be the first like few terms. So we have n squared then. Now what we're going to do is take them away, and you'll see what happens if you don't already know. If we take the terms away, 3 minus 1 is going to be 2, 9 minus 4 is going to be 5, 17 minus 9 is going to be 8, and 27 minus 16 is going to be 11. Now, what do you notice here? It's a linear sequence because it's going up in threes, right? Now, this linear sequence is actually bn plus c. So then, well, b is the common difference, which is 3. It's going up in threes. And c, well, if you go back by 1, if you're minus 3, you're going to get minus 1. So c would be minus 1. So we found b and c. So therefore, the whole nth term becomes n squared add 3n minus 1. And that is your nth term there. Okay, and the reason why that works is because essentially what we're doing here is, if we make room here, this sequence, the top sequence, right, is n squared at bn plus c, and we're taken away by the sequence n squared. If we're taking n squared from n squared, you're just left with bn plus c, which is what we've got here. That's why it works the way it does there, if that helps you remember. But that's the strategy. So you find the first difference, and then the second one, like with a linear sequence, then the second difference is 2 lots of a is equal to that number. Then you consider the sequence an squared. In here, it's just n squared. Take them away by the terms, then you get the linear sequence for b and c. Okay, there we are. That's just a rundown on that. Cool. Question 11. Again, iteration question, very common. It shouldn't be too bad either. It's the same sort of thing, really. They don't really try to complicate iteration questions too much. So part A, show that this equation here can be written in this form. So this is very common. You have to rearrange the equation so x is in terms of some other way of x, right? So the best way, well, you can kind of work backwards if you want to. So you could say x to the 4 is x squared add 5. So because you're rooting it by 4. And then actually notice we're rearranging, so we rearrange this to get x to the 4 is equal to x squared add 5, okay? And then we do the fourth root, so then x is the fourth root of x squared add 5, and we've rearranged it. Cool. But you just have to spot that sort of thing. But if it helps to undo the equation a little bit to show what you need to do, then you can do that. But yeah, that's how we approach that. So you need to rearrange one of the x's. That's where the difficulty can be. But hopefully you can see, because we're rooting by 4, we're going to need to get x to the 4 on its own, like we've done here. And then we can root by 4. Anyway, so that's for part A. Very common question as well, to rearrange it. Then we have an iteration. So we have x0 is 1.5, and you need to use an iteration formula to 3 times to find an estimate, which again very common. So you just need to plug the starting value into the formula. So if x0 is 1.5, the next one's going to be x1. Okay, so then that's telling us the next x here is x1. It's going to be the fourth root of x0 squared add 5. But we know what x0 is. It's the fourth root of 1.5 squared add 5. And so what will that number be? You just put that into the calculator, right? So you got to bear in mind it's to the root of 4, not 2. So you need to pick the right button on the calculator. So the fourth root of 1.5 squared add 5 will get you this number here. 1.640909017, and you do pretty much have to write all the numbers on your calculator. That's just how it is. Um, uh, but then x2, and then we reuse the formula, and then we're going to plug x1 into here to then get x2, the next number. But if we call this, this will be ands on the calculator, right? So then, what I'm going to say is actually, I'm going to put in the calculator the fourth root of ands squared add 5, because that means the previous answer we can reuse to get the next number, instead of having to write out this nasty decimal. Okay, so if I write this into the calculator, I then get the next number of 1.665398002, and they're going to do the exact same again. And I can just press equals, because and will now be x2, the last number. And so if I press equals again, that's going to be 1.669763088. and that is your estimate. We asked to do it 3 times. That's the third time. So that is your estimate here. 1.6697630888. Then it tell you to what when to round it. So you just have to write the whole number in this case. Because iteration, the decimal points matter. So you do need to just write all the numbers. But hopefully that's clear, right? And that's really what leads to iteration. In my opinion, fairly nice marks, in my opinion. And it always is the same sort of way. It's the same question every time, really. Okay, question 12. Circle theorems, everyone's favourite. I'll let you read that. I'll tell you what I'm gonna. Yeah, I'll let you read that because I'm gonna zoom in a minute. Uh, okay. So what's going on here? So, we are given this very sort of nasty diagram. We are given 4 points A, B, and C. AC is the diameter, which is here. I don't know if you can see that because it's passing through the centre. And then we give a straight line. So basically, everything is on the diagram. We don't need to pay attention to the words. So what I'm going to do here is I'm going to actually zoom in to really see what's going on here. There we go. Really zoom in. So the angle we need to work out is BDC. So BDC is this triangle here, right? Hopefully you can see. So BDC is going to be this angle here, and that's what we're going to work out. Okay. So let's have a look at our diagram. Oh, it's slowing down a little bit. So let's have a look at this diagram. So what circle theorems can we immediately deduce? Well, the one thing that's staring at me is the alternate segment here. So I have the 35 here, and it's this is going to be 35 as well, because what's going on here is this situation here of this here with the centre at C. So these two angles are going to be the same because they're in the same segment. So that means angle CBD is 35 degrees uh, because angles in the same segment are equal. Cool. Okay, what else can we deduce? Well, what I also noticed is uh, the fact that we have a semicircle in a triangle and a semicircle, because this is a diameter, so that's going to be a clue that we're going to need to use the fact the angle in a semicircle is equal. So that means if we have, oh, that's a rubbish triangle. If we have a diameter, say here, then if we then at either point of the diameter, it extends to another point on the circumference, that point is going to be a right angle. And that's what's happening here. If you notice that that we have the diameter here, which is drawn, and then we have this triangle here, and you can see the 2 point up the opposite end of the diameter are meeting at D. So that tells you that this angle's x, by the way, that this whole angle of x and this bit as well is 90. Okay, hopefully you can see that. So then I'm going to say angle uh, uh, ADC, because obviously that's a triangle, ACD, is going to be 90 because the angle in a semicircle, because that's what the diameter does, it's creating a semicircle, right, is right angle, which means 90 degrees. So those are the two things that's staring at me, right? So what else can we do from that? What can we do now? Um, well, I notice that this is a triangle as well. DCE. And why is that important? Because I think I can work out this angle here. Because if this is on the pot, so this angle would have to be 90 as well, wouldn't it? Because this angle is 90, and so it's on a point here. Hopefully you can see that it's on a point. So obviously angles on the point add up to 180. So that means if this angle on the left is 90, then this angle is also going to be 90. You don't have to write that down because if you remember what the question said in this instance, write down any circle theorems you use. So you don't need to make reference to things that are not circle theorems. So here I'm just using the fact that angles on the line add up to 180. That is not a circle theorem. But I could say if you wanted to, angle in this triangle CDE is 90. Because of the fact, as we discussed, on the right angle. But then I could work out this angle then. That I can then work out this. So then angle DCE, again, the angles in a triangle add up to 180. So it's going to be 180 minus 28, this angle here, minus the 90 to get the missing angle. And that will be 62. Okay. But then I notice another triangle here. I'll draw it here. It's this triangle here, ACD. Because now I know that we have a 90-degree here, and we also know this angle's 35. Then I know this angle here, don't I? And this angle is going to be angle. What angle is this? ACD. That's going to be 180. Again, take away 90, take away 35. And that's going to be 55. So this angle is 55. And now I know this angle as well, don't I? I know this one because I know this angle, remember, was 62. I forgot to add that on. But we know this is around, again, on the line. So that means this angle has to be 180. Take away 55, take away 52. 62, no? So therefore, angle. Oh my God. So this angle here, which is what? BCD. That's going to be 180. Take away 55, take away 62. And that will get you 63 degrees. So that angle will be 63, okay? Because here, what I'm referencing here is obviously we're on a line. So these three angles here have to add up to 180. So I can find out this angle here, which is 63. So what can I do? I've got a lot of angles now. What can I do with that one then? So again, the key thing is to work out the triangles we've got. Well, I can find X now, can't I? Actually, because of this angle, this triangle here. If you notice, if you tilt your head a little bit. Oh, there we are. B, C, D. We know this angle's X here. Let me scroll up so you can see it better. We have an angle X here. So this triangle that we're working with, this triangle here, that is X. That's going to be the combined angle of 63 and 55, isn't it? So 63 and 55 is 118. So this angle is 118, and this angle was 35, as we worked out because of this same segment stuff, right? So then we work out x. So again, so x then, which is angle BCD, or BDC, sorry, that's going to be 180 minus 35 minus 108. And that's going to be 118, sorry, and that would be 27. Okay, let me check that actually. I think when I did it before, I think it's 29, wasn't it? Let me have a check. I'm going to check that one because that's a very nasty question. Oh my lord. But I believe that should be the method for it. Let me zoom out now. There we are, so you can see the full picture. Okay. Uh, the angle's 27. Okay, cool, got it right. Okay, cool. Yeah, that's the method. That's a very nasty circle theorem question, but that is the method, though, how I went step by step. You think about what usually, again, it's pretty obvious what circle theorems you're going to use first. Oh, hang on a second. I'll be back in a second. Hopefully, you have time to digest that. That is a monster question. That is wow. But as I say, yeah, that's the process, right? Usually, there's a circle room staring at you at the face. So here, I spotted there's an alternate same segment immediately. And then I also spotted we had the diameter. It said diameter, so we're probably going to have to use the right angle in a semicircle. And then I went from there, right? I then considered what triangles we had, and then worked out all the missing angles, and then went from there. And then eventually I got to X. But that's the idea, right? Use the missing information to work out other stuff, and then other stuff from that, and then other stuff from that. Then eventually you get to X. Okay, for only 4 marks as well. Only 4 marks. My God, I would put at least 5. Oh, I don't know. Anyway, hopefully a bit lighter now. Question 13. So we have a graph of f of x. And again, this is very common. So the one just to do some graph transformations. So the first one is f of x minus 4. So what I'm going to say here in general is first of all, everything outside the function affects the y values. So here, f of x, the input itself, x stays the same. So it won't affect the x values, but affect the y values because outside we subtracted by 4. Now, if we change y, so here we change the y as we discussed, but we're going to minus 4. You do what you expect. So what I mean by that is, if we are subtracting by 4, you're going to expect to subtract the y coordinates by 4, and that's exactly what we're going to do. And so you can do it one by one. So here the y coordinate's 0, so it's going to go down by 4. So it's going to be here, 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 and then here, right, to minus 4. Then we're going to do the same here. So it's y1, so it's going to go down to 1, 2, 3, 4 here. Then I'm going to do the same here. It's going to be here, right? As we can see. And then here, again, it's going to go 1, 2, 3, 4 here. And then we just connect the dots, right? And then we get this shape here. Obviously, it's a bit. Let's try to make that a bit better. There we go. And that would be your transformed graph. Hopefully, you can see that. Now, why do I say this? I mean, it might seem a bit obvious, but if instead we change the x value, so if we said of half of x, for example, no, hang on, no. Let's choose a better one first. If we had x minus 4, for example, you'd think, obviously, that's affecting the input, so it's going to change x. You'd think you subtract 4 from the x coordinate, so you're going to go 4 to the left, aren't you? But you do the opposite. So instead of subtracting by 4, you're going to do the opposite and add 4. So you do the opposite. Likewise, if we had say if we had f of 3x, you'd think to times the x coordinates by 3. But instead, you're going to divide by 3. Because you do the opposite. And yeah, that's really all I've got to say, really. So, like I said, y, you're minusing 4, so it's outside, so effect of y, and you do what you expect, so you subtract 4. Okay. Then it's asking, oh, I did it on the graph. I was meant to do it on the other graph. It doesn't matter. I was meant to do it on that graph. Never mind. Then it says to draw the graph of f of a minus x. I'm going to do it up here then as well. F of a minus x. So again, you can memorize this as a reflection, but I'm going to show how to do it, really. Again, it's fairly straightforward. Well, this is of the f of minus 1 times x. So you'd think to times the x coordinates by minus 1. So you change the sign, right? But obviously we divide it by minus 1 because we do the opposite. But dividing and minus it and multiply by minus 1 is the same thing. Essentially, the times in a divided by minus 1, you flip the sign. And that's exactly what we do. With the x coordinates, we're going to flip the x sign. So here we're on minus 3 for x. That's going to go to positive 3. Here, minus 2 is going to go to positive 2. And this point is going to go from minus 1 to 1. And here, 0 is going to go, well, it's going to remain the same, right? And then we just connect the line again and get this shape instead. Again, I said you could memorize this as a reflection in the y-axis, but I don't learn that because of this thing here. If you just make sense that you just divide the times the coordinates by minus 1, you're essentially flipping the sign, and then you connect, draw the point, transform the points and connect them, and then you get the shape. Hopefully, that made sense. But yeah, again, transformations will come up, absolutely. They come up every year, so it's good to practice these. Again, if you just learn this rule here, what I've just run over, it shouldn't be too bad. If you haven't learned already, anyway. Or obviously, if you have your own way, like I keep saying, if you have your own way that works, then obviously go for it. But I'm just giving a different way and showing how to approach it. But yeah, so now on question 14, and this is about simplifying algebraic fractions. Right, we have an algebraic fraction of algebra, and we need to simplify it to this. Again, very, very common exam question. And this is very common, so they love asking like multiple different fractions like this. The way is again, do it part by part. So let's do this bit first, and then work our way out. Okay. So first of all, let's investigate inside this big bracket here. So we're going to do x plus 4 divided by 2x squared minus 6x minus 56 over 2x plus 3. Okay, so first of all, notice we're dividing. So you should know with fractions, dividing means keep flip change. So you keep the first bit, and then you change the sign, and then you flip the fraction. So it would be 2x plus 3 over 2x squared minus 6x minus 56. Um, and then I'm going to say, well, I'm going to type across, right? So I'm going to say it's x plus 4, 2x plus 3 over 2x squared minus 6x minus 56. Now, we could add then the next bit, but What you need to do essentially is everything needs to be factorized if we can. Everything. That's the main idea because things will cancel. And here I notice this is unfactorized, so I think it's best to factorize it if we can. So, how do we factorize a quadratic like this? And this is good revision for this as well, actually, to factorize stuff. Now, we can't do the normal way of just considering this number and this number, 56 and 6, because we have the coefficient is not 1 on the x squared. What we do instead is times this coefficient by the number on the last number, the constant, and we then instead have 112. 56 times 2 is 112. Then we do the same method. Then we think of two numbers that add to give -6 and times to give -12, right? All we've done really is just times the 56 by 2, and then we do the normal method for factorising. So the best way to think of this is think about the factors of 112, right? And then think about what pairs of numbers can give us 6 or -6. So obviously we have 112 and 1. Then we're going to have 2, and then that'll be 56. What about 3? Well, you could do 112 divided by 3, but you won't get a whole number. So 3 is not a factor. What about 4? 112 divided by 4 gets us 28. So that's a factor. What about 5? No, because it's ending 5 or 0. About 6? 6 divided by 112 will get us not a decimal, so nope. 112 divided by 7 gets us 16. That's our next factor. But 16 plus 7, 16 minus 7 doesn't get us 6, so that we can't consider that. Then what about 8? 112 divided by 8 gets us 14. And actually, yes, we're in a good point now, because 14 and 8, their difference gives me 6. So I think I can work with that. I can work with that. Wow, what should I do to get -6? I'm gonna have to make the big. I want a negative, so we're gonna have to -14 and +8, because -14 add 8 would get us -6, and we times to get a minus number, because a minus times a positive is a minus. So this will be our number, -14 and 8. That tells us essentially what this tells us is we can split the -6x into -14x and 8x. That tells us how to split this. And you can see that's useful in a minute because we can factorize with that. Hopefully you can see that because -6x is -14x add 8x. This simplifies to -6. Hopefully you can see that. So I'm going to bring that in. So 2x squared -14x plus 8x and -56. Okay, this is why the method works. So now I can factorize both parts. So 2x is a common factor, so that could be x minus 7. And then I notice 8 is a common factor, so I'm going to x minus 7. Then I notice x minus 7 is a factor of both. So I can say that's the same as x minus 7, and then 2x, and then add the 8 here. And then what I also notice actually, 2 is a factor we can pull out here, 2x and 8. So I can say that's 2 lots of x minus 7, and then x plus 4, right, by taking 2 out. Okay, so that's factorising. You could alternatively, I think you are meant to show the method here, but you could check your answer by checking the roots. Okay, if you solve this quadratic, and you should get the root 7 and -4. And actually, you can use that to help you factorise, because if you know 7 and 4 minus 4 roots, then you could say x minus 7 and x plus 4 equals 0, and then you make sure, obviously, this would give 7 and -4. But that's the approach, okay? Very, not the nicest quadratic, is it? Oh dear. Now it's factorised, we can bring that in. So that will be x plus 4, 2x plus 3, of 2 of x minus 7, x plus 4. And now look what happens. I have a common factor on both. If I have the same number top and bottom, I'm divided by the same number, so they will cancel out to 1. So they will cancel out. And then I'm left with 2x plus 3 over 2 lots of x minus 7, which is down here. Okay, so that was only this bit in the bracket here. We now need to add this with this bit here, 14 over 3x minus 21. So that's what I'm going to do. So I'm going to add this with 3x, no, 14, wasn't it? 14 over 3x minus 21. Okay. Yes, that's right. Okay, so we're adding two fractions. So we need to consider the denominators. They need to have a common factor. But here I spot the 3x minus 21 factorizes, doesn't it? I can factor a 3 out. So that's going to be 3 of x minus 7, right? Because that will give me 3x minus 21, which was what we got. And now, look, I have a common factor of x minus 7. So if I'm adding, I now just need to times across by the 3 here and times this across by the 2. So this first fraction are times by 3 to get 3 lots of 2x plus 3. And then I'm going to add, and then I'm going to times by 2 of this. So it's going to be 2 lots of 14 over 3 times 2, which would be 6, to get a common factor. 6 lots of x minus 7. And then I can expand and simplify. So this will go to 6x of 9 add 28 over 6x minus 42, right? And so that will go to 6x, add 9 and 28 will get me 37 over 6x minus 42. Okay. Wow. It's in this form, isn't it? Okay, we got there. There we go. AX plus B over CX plus D. So obviously here, if you compare, obviously then A would be 6, B would be 37, C would be 6, and D would be minus 42. Okay. But you don't have to do that. But it's in the form, so that is our answer. There we go. Got there in the end. That is not nicest one either. But yeah, that's generally the approach with algebraic fractions. First of all, if you've got multiple, which is very likely, do it fraction by fraction. So do this bit first, the division, then add it with the fraction after, which is simplified. And to simplify, aim to factorize whenever you can, and then things should cancel. Okay, things will cancel. That's the whole point of the question. And then you go from there. Okay, but I am going to move on now. Question 15. Okay, let's have a read. Okay, so it says a race is measured to a distance of 10.6. Correct, to the nearest 0.1. Sam runs a race in the time of that to the nearest second. His average speed is v. We need to consider bounds to calculate the value of b. Now, how do I know it's a bounds question? Because it's, again, giving stuff around you to the nearest, like, accuracy, the nearest point, right? Again, correct to the nearest 0.1 kilometers to the nearest second. There's rounding, which means there's bounds, okay? Which we talked about the error interval question. So this is going to be a bounds question, and they made it clear by considering bounds. So what that means is we need to find the upper and the lower bound for v, which is what we want to work out. So v is speed. So you need to realize, again, you can use this formula, this triangle, distance, speed, and time, like with the density stuff earlier. If you want the speed, you cover that up, so you're left with d over t, d divided by t. So that's going to be distance over time. And that's essentially where we're going to calculate our v as speed. So if we're going to work at the bounds of the speed, we're going to need to work at the bounds of the distance and the time. So the distance and the time are rounded, so we need to work with that. So let's first of all let's deal with distance, which is d, for example. That's going to be 10.6, right? We need to, it said 2.6 is rounded to the nearest 0.1 kilometer. Now 0.1, that's to the nearest decimal place, right? So again, like with the error interval, let's consider going up in 0.1s, right? So if it adds a 0.1 to this, it's going to be 10.7. And if you go back, it's going to be 10.5, okay? Then the lower and the upper bound is going to come from the middle. So it's going to, again, the middle of these is 10.55 and 10.65. So the upper bound here is going to be 10.65 and the lower bound is going to be 10.55, okay? So that's the distance. Now the time is going to be 31 minutes and 48 seconds to the nearest second. Okay. Okay, this is where it gets complicated. But really, all we're rounding is the second. We can actually ignore the 31 minutes, can't we? So T's 31 mins and 48 seconds, right? We only rounded the second part, so let's just do the upper and the lower bound of 48. So again, 48, let's do it here. 48 seconds, the next second is going to be 49. And then the second before it's going to be 47. So again, the lower bound is going to be 47.5 and the upper bound is going to be 48.5. So that's 47.5 seconds and 48.5. So therefore, our overall upper bound, T upper bound, is going to be 31 mins and 48.5 seconds. And our lower bound is going to be 31 mins and 47.5 seconds, right? Because that's the lower bound of our seconds. So that's our upper and lower bound for our time. Okay. So now we've found the bounds of the distance and the time. So now we can in a position to find the bounds of the speed. Okay, but what do I notice here before I go any further? I also noticed that the units are kilometers per hour. Well, the distance is in kilometers, but our time is all over the place. It's in minutes and seconds. We need to convert the time into hours, actually. So what we need to do is, before we go any further, we need to convert both of these into just an hour. Okay. So the best way of doing this, I think, and this is quite nasty in my opinion. This is quite nasty. I don't know, Edexcel. What are you playing at? But the best way to convert to hours is to convert all of these individually into hours. So you convert the minutes into hours and the second part into hours, and then add them. So what you're gonna first of all, you should notice that actually there are 1 hour is 60 minutes. So we're gonna need to do some conversions. That's what we're doing now. Now, actually, to get to 31 minutes, I think the best way is actually saying 1 minute. Sorry, if 1 minute would be 60th of an hour. So if we divide by 60, we get 1/60. That'd be 1 minute. Therefore, to get to 31 minutes, we're going to times 1/60 by 31. So 31/60 hours, right? Oh. And that would be, I don't think that'd be a nice number. I'm going to leave that there, I think. So that's 30. So we convert to 31 minutes into hours, right? Now, what about the seconds? So, as 1 hour equals 60 minutes, we know that also 60 seconds are in every minute. So, that's going to be 60 times 60 seconds, which is 3,600. seconds, right? Again, and then I'm going to divide by 1,600, 3,600 of an hour is 1 second. Then I can just times by 48.5 and 47.5, okay? So therefore, I can say 48.5 secs is going to be 48.5 divided by 3,600, so times by 48.5, and then also 47.5 seconds is going to be 47.5 over 3,600. So now that's all in hours. So now everything's in hours. So now we're going to bring it all together. So that's going to be 31 minutes, remember, is 31 over 60. And then 48.5 seconds is this number here. 48.5 over 3,600. I'm gonna make room for this actually. So our lower bound again, if I rewrite this, 41 minutes and 47.5 seconds. If you put that into a calculator, 31 over 60 add 48.5 over 3,600, you get this decimal, right? 0.530138 and so on. Then we do the lower bounds again, 31 minutes in hours is 31 over 60, and then 47.5 seconds in hours is this number here, 47.5 over 3,600. If you aren't comfortable with fractions like this, you can just convert to a decimal. That is fine, but you do have to pay attention to rounding. Okay, that's what I will say if you go through that. So then that would be instead 0.529861. So now again, so that's in all hours now. That's great. So that's in hours. This is in hours. So now that's great. So we've got time in hours. So now we could just find the speed. So going back to this then, so now we need the upper bound for speed. So it's going to be v of firstly the upper bound. How are we going to get the upper bound of this here, this fraction? Well, the distance is going to have to be up higher. It's going to be the upper bound for the distance, which is 10.65. Hopefully you can see that here. And the time has to be the lower bound. Why? Because if we have a big number and then divide it by a small number, that's going to give us a big and overall number. Think about it like this. If we had, say, 8 over 2 and then 6 over 3, if we make the number bigger, 8 over 2, and make the denominator smaller, that'll be 4, and 6 over 3 will be 2. Clearly, the first fraction is bigger. So making the top number big and the bottom number smaller gets us a bigger number. So that's the upper bound. So a lower bound for time then, hopefully that made sense. The lower bound's here, right? This number here, 0.529861. And then you put that into the calculator. You get 10.65 over that. You get this result here, 20.09960682 kilometers per hour. Make sure it is best to write all the digits because again we're dealing with bounds, so the decimals do matter. And then the lower bound is the opposite argument. So we want the fraction as small as possible. We want a smaller top number. So we want the lower bound for the time, the distance, sorry, which is 10.55. And we want the upper bound for the time. So we want the bottom number as big as possible. Now the upper bound is this number here for the time, 0.3530138. And put that into the calculator. You're going to get 19.90047,874 kilometers per hour. Okay, so we've got our bounds. Now we just need to work out what value we can have. So I'm gonna just do I have space here? I am. I'm just gonna reiterate the upper bound is 20.09960682, and the lower bound was 19.90047,874. Okay, we've got our bounds. It's asking us to calculate the value of b to a suitable degree of accuracy and y. So again, this is very common. When you worked out the upper and the lower bound, you have to find the number where they both round to the same number. So here, clearly, if I went to, say if I went to one decimal place, that would be 20.1, but this would be 19.9. They are not the same. So then I then have to move up. Then I'll consider the this digit here. So the whole nearest whole number. So that's going to be 20. That I round up to 20. And then this will round up to 20 as well, because 19.9, the 0.9 will round it up to 20. So actually, our final answer is going to be V is 20 kilometers per hour. Two significant figures, obviously, because that second significant figure, because the upper and the reason is always the upper and lower bound both round to 20 when it's two significant figures. Okay, if we did any more than that, if we then went to the decimal point like we just discussed, that would go to 20.1 and that would go to 19.9. They no longer equal. When the upper and the lower bound are equal, you are saying that the maximum and the minimum value are the same. So if the maximum is equal to the minimum, that means anything in between is also the same. So that means V has to be 20 at this for any bound, right? So if it's 20 and the upper and the lower, then it has to be 20. And that's how you go about it. You find the number. You keep going. You keep considering the digits until it rounds to a different number, and then that's it. Okay, that's a very nasty lower. I didn't expect these questions to be so nasty. They looked fairly innocent first when I first picked the questions. I thought there would be too much work, but I apologise. But hopefully they made some sort of sense, right? If if these questions make sense, let's just say you should be prepared. You should be well prepared for the questions that will come up on these topics tomorrow. Let's just say that's the good thing. But we're on the final question now. And okay, I don't know what's going on here. There we go, it stopped. And it's a classic sort of. They ask this pretty much every year as well, mostly. And usually it's a final question, and it's to do with circles and lines, right? And tangents. So this question says a circle. I've scrolled up so as you can see the marks and the paper. By the way, if you are really struggling with one particular question, I did put the paper it came from, so you can have a look at it if you really want to. Should have clarified that. But anyway, so this final question: a circle has equation x squared and y squared is 12.25. The point P lies on the circle. The coordinates of P are 2.1 and 2.8. The line L is tangent. Find the equation of L. So the best thing with this is to do the graph, right? If you have a circle and stuff like this, draw the graph. So you should recognise that a circle has the equation x squared plus y squared is r squared, but r is the radius. So if the radius is going to be root 12.25, which is going to be what? You don't. It's going to be 3.5. Okay. So that's telling you from the center, which is the centers of the origin, then it's going to be 3.5 outwards on all the axes. So if I then draw 3.5, it's going to a bit of a rubbish sketch, but you get the point. It's going to look like that, right? The circle centered at 0 with a radius 3.5 on the grid. Okay, hopefully that made sense so far. Then we're given a point P, which is 2.1. That's going to be about there, and 2.8. So it's going to be about here, right? P. So that's P is 2.1, 2.8. Okay. Then we said the line L is a tangent to the at the point P. So the line L, it's a bit rubbish again. L is going to look like that, right? It's a tangent at the point P. Although I didn't make it look like it, but that's what it's going to look like. That's all we're given. So actually, once you do the diagram, it should make it a lot easier. And the general protocol is, you consider the radius, okay, the line of the radius, which is here. Y, well, you should know that if this is the radius and that's the tangent L, they are going to be perpendicular, which means they have a right angle, and we can work stuff out the gradient, right? So this is going to be a right angle here. So that means, well, tangent is perpendicular to radius. You don't have to write that, but that's what's going on. And that's generally the first step you want to make with these sort of questions. And that's the circle theorem, right? And yeah, so what we're going to do is, well, if we find a grade of a radius, we can find the grade of the tangent. But we know the grade of the radius, m of the radius, because we know that the center is 0, 0. And that's on the radius. And we know the radius also goes to the point P. So really, the radius is between the gradient between those 2 points of the change in y. Oh, hang on a second. Oh, okay, we're delivering 5 minutes, so let's wrap this up in 5 minutes. Anyway, so that's going to be the change in y, the gradient over change in x. That's just a normal gradient, right? But then we know the 2 points, which is O, 0, 0, and P, which is 2.1, 2.8. Those both lie on the radius. Hopefully you can see that, because obviously the radius will pass through the center. So then the gradient, the change in y is going to be 2.8 minus 0, and then the change in x is going to be 2.1 minus 0. So the change in the y coordinates and the x coordinates. That's just going to be 2.8 over 2.1, which is going to be 4 over 3. So that's our grade of the radius. Now, we said that the tangent is perpendicular to the radius, so therefore the grade of the tangent is going to be the negative reciprocal. So negative and then reciprocate it, right? 3 over 4. And you can check your answer, because if you times the two gradients together, you should always get -1. So that'd be minus 12 over 12, which would be -1. So that's cool. But it's just a negative reciprocal. So do the reciprocals and do the negative. No matter what order you do it in, if you want to negate it first or reciprocate it, you do the negative and the reciprocal it. So that's our tangent. So therefore our line is mx plus c, but we know our gradient. So it's going to be y is -3 over 4x plus c. So that's our tangent, cool. But we also know, again, the point P lies on the tangent too. So P, 2.1, 2.8, if we sub P into this equation here, for our tangent, remember, that's going to be 2.8, it's going to be minus 3 over 4 of 2.1 at C. And then, again, we can simplify this. So 2.8 is 3 over 4 times minus 3 over 4 times 2.1, which is going to be minus 1.575 at C. And then you just literally add you add 1.575 to both sides. So then C is going to be 2.8 add 1.575, which is 35 over 8, which is what the calculator gives me. 35 over 8. So therefore y, now we know our value, it's minus 3 over 4x, add 35 over 8. We've got the equation, cool. So let's just check the answer. Okay, asked to give it in this form. So ax plus byc, where all the coefficients are integers. So, okay, let's first do that then. So let's get x and y on both sides. Oh, for God's sake. Why are you playing up now? Come on. It always gets to this point towards the end. It's just too much for the laptop to deal with. Uh, oh my God. What's going on here? Oh, for God's sake. Literally need to do one more step and then we're done. And now it wants to play up. There we go. So we're going to need to add the x and y's on both sides. So it's going to be 3 over 4x add y is 35 over 8. So remember, it needs to look in the form ax plus by equals c. But they need to be integer. So I'm going to need to get rid of all the fractions. So I'm going to have to times by 8. Right? To both sides. So then 3 over 4 times 8 is going to be 6x. You can put that in the calculator if you want. Add 8y is going to be 35. And that is your equation. Okay, and that's it. So that's the general format, right? With these circle line questions, you always should consider the radius, okay? And then you should realise that it's going to be perpendicular, and then you can do stuff with gradients and then work out equations of lines, stuff like that. Okay, so that is the GC revision done. I am going to have to go off it just a little bit, but I'm going to come back on and do A level. Obviously, that won't really concern GCSE people. But I will be uploading this into YouTube right after this. So if you want to watch it the night before, then if it's to help before in the morning, before the exam, go for it. But I do hope it all goes well for you tomorrow. Hopefully these questions will be of much use to you because you will see questions like this on your exam. I pretty much guarantee it. They come every year in the same sort of format, so this should be of good use to you. But I hope it goes well. But I am going to leave it there then for now. So thanks for watching.